I also wanted to do, but I wanted to do both, but I got to do only one. So those kind of situations come. Then we have the sub-electives for the next semester, which is kickstarting innovations, which is about brand creation, how to sell your products, And then we also have like urban biosystems. So again, looking into intersection of biology, new interfaces like AR and VR. So they teach in depth that also, like, and we also have advanced robotic fabrication, the one which I showed you as the third term. Yeah, it's pretty much that is our curriculum. And yeah, so these are the main. I covered all the subjects that it's taught in 1 year, and the next year, if you want to do, it's optional. Like second year, which is mostly thesis oriented, so you will choose a particular guide for you. There are people coming in from UCL or even other colleges like IAAC, and they have one students, like a group of students for them, and you can choose what you want to do. And even some there are teachers from IAAC who is handling the groups. So, but like, so most of the teaching happens in the first year, like the most intense, like the overflow of data, so which you choose, like what you want. Like, for example, for me, I found grasshopper to be the most needed for me, like beneficial for me. I completely didn't look at processing, because I knew I could do the coding to create that kind of, art in grasshopper itself. So would I learn a new language like Java, because Java is also not my favorite. Python is good, like I like Python, so Python as an option in grasshopper as well. So Arduino is also a topic which I'm interested into, but time constraints are there. Now I'm getting time to do things because of this pandemic situation. Workload is there, so I'm exploring computational design itself, because that's the first topic which I want to cover in depth. So now on, I'll talk about the masters. So basically, IAAC has 3 terms. IAAC has 3 terms, and in the first term there is basically 3 studios. So it's called Machinic Protocol, Morphogenesis of an Urban Photobioreactor. Then the third one is called Metabolic Gardens. So I was in the second studio, which is called the Morphogenesis of Urban Photobioreactor. But I will also tell you about the other 2. The first one is machinic protocols. What they basically do is they would develop sensory devices, and they will deploy it into some spaces like environments and public spaces to collect data. Once they get this data, they will generate cartographical drawings out of it for presentation in the first exhibition. And then later what they do is they create performative models using these. And these performative models would exhibit the changes in that analyzed space over a period of decades. So that's also an exhibition, and that's about the final presentation, what they do. And my studio was the morphogenesis of urban photobioreactor. Actually looks into the intersection of biology and computational design into the making of urban photobioreactor, which is looked up to as the future of food consumption and production. And also it enlightens us to the fact that our bio-environment is our profit. Like it's paradoxical to the Anthropocene age. But now we have a realization, like if you look into the pandemic period, we don't have the usual normal that we have. We are waiting to have it back. So we look at it like a profit. So this studio also looks into like how we can look at what we have as a profit, and also work for the future in a way like future of cultivation and things will be like through things like photobioreactors and stuff. So that's enlightenment into it. So it's a group of 4 people. So this was the morphology of our urban photobioreactor. It had 3 branches. You can see the 3 branches, right? And what the technique that we use for this is the lights. We use lights to affect the way how the spirulina is being used. In this project, we have this digital introduction to digital fabrication. Then we have something called Prodino, which is an introduction to 2 main open source software, which is processing and Arduino. So what Arduino does is it's actually a microcontroller which can be programmed using C++ programming or C, and you can use it to create the devices, even robots to perform particular functions. So mostly it is software and hardware oriented, but it is the main hardware that we use to connect to the computer for various functions. And then we also have the processing, which is a programming language for visual arts purposes, and it is based on Java. So the syntax is very similar to Java. And our final project is the combination of how we combine Arduino with the processing to achieve particular tasks. It's very introductory, so it's a very vast. All the topics that are introduced in IAAC is very vast. So you can take the direction on which software you want to enlarge your interest into. So I was like an architect. So my most interest was into generation of functional and form-based designs. So I'll just share my screen to show one of my processing projects, processing and Arduino combined project, and it was very beginner level. But for the initial observation, it was good. So what I did was, yeah. So in my group, we used an accelerometer, and we programmed the Arduino, and then we made this like a computational art bubble flow in processing, and then we connected the accelerometer along the Arduino to the processing image in the computer, and we are dynamically trying to control it. So this was our initial basic understanding of, then we could develop much more intense things. For example, for the photovioreactor that we showed, we also used to control the lights, color of the light, because we used only multicolored LEDs for this, and we programmed it to give the particular light, and the mother cell would keep changing its color from blue to red to violet. So that's how we control, and we try to implement it to simple techniques. So that was another introductory session. So we have the 3 studios, then the fabrication, and then introduction to processing and Arduino, and then the most important topic is the computational design. Actually, that is the most important subject of IAAC. It's the only subject which is taught in all the 3 semesters. So I will take computational design together. I'll explain to you like how they are carried out in all the 3 semesters. So the first, they will have introduction to grasshopper, which is our main tool in IAAC is grasshopper and its add-ons. So in the semester 1, term 1, we don't use any plugins of grasshopper. We just use pure grasshopper. They make us understand the basics to get a proper base of it, because that based on that only we can develop further. Most of the internet tutorials, they fail in that way. They try to show a process and people try to use their algorithm and then take it from there. But it's very important to have that base, like to understand data trees, sets, lists, etc. to, actually create your own algorithms to do the designs. So that's what they do first, and you get a proper base. Then they'll ask you to reverse engineer parametric design, like for example, serpentine pavilion or something. Look at how it's created, use the algorithm to reverse engineer it. They'll support you to develop it also. Then what they do is they also introduce you to animation in Grasshopper, how you use the sliders to create animation. And then the final project is using all of them together to develop a project. So that will be the end of the first semester's computational design. In the second semester, they introduce you to 2 main plugins, which is the Anemone. So what they're doing is, I was in a digital matter. It is in 3 different scales. So digital matter is in the material scale, self-sufficient building is the building scale, that's urban design is in the city scale. So what they do in digital matter is, all the 3 research lines will have their research trips. I came to US, I went to MIT and Harvard to see their works. They have this mediated matter group in MIT, so it has similar works to what the digital matter does. So digital matter looks into the intervention or the introduction or the use of intelligent material into construction. Intelligent materials such as graphene, which can be programmed to collect data, and this data can be used for the creation of like dynamic spaces, responsive spaces. And this looks mostly into the intersection of advanced topics like artificial intelligence, thermodynamics in materials, physical computing into creation of these dynamic spaces. So the next studio is self-sufficient buildings. It looks at buildings as metabolic machines that would counteract to the changes in the environment and its surroundings by the creation of systems like building facade systems, or it can be like some kinematic designs, spatial organization, things like that. So what it's urban design, which is the 3rd research line, what they look into is the design of urban design for like concepts, which look into the emergency situations such as rise in water levels, and they would design using techniques like degeneration or release of spaces to give relief. So that are the three of the research lines. Then we also have the 3 electives, which is the main electives are like computation and drawing. Then we have something called mushrooms, which deals with design using Karamba, which is a parametric engineering system plugin. The 3rd one is called urbanization. That is also going to last all the 2 semesters. So what they do in the most important here is like what I was a part of was on drawing and computation. So what on drawing and computation does is they look into the use of algorithms and codes to create line drawings and bifurcation. Bifurcation is one of our very cool subjects. What bifurcation does is bifurcation is led by Mark Burry, who is the current architect of Sagrada Familia. And what they're doing that is the students would look into the computational tools into development of column designs, variation of columns. So because they are looking into the work of architect Antoni Gaudi, who's a actual architect of Sagrada Familia. So, and in the inside of Sagrada Familia, he has these columns which are separated into branches. That's why the course is called bifurcation. The columns get divided to show the branches. And what the students try to do is they would use computational techniques to create a much more variant designs of the columns and also later fabricate a small module of it in the lines of the lyricism of Antoni Gaudi's expression of like how you worship under a canopy of petrified forest. That's what the theme of the that one is. The problem is I was not a part of it. I wanted to be a part of it, but in IAAC you can only choose one elective, one research line and things like that. Sometimes you might not end up in what you want to do, but you will look up to another line. So if I had a chance, I would have gone back and done bifurcation and also self-sufficient buildings maybe. Yeah. And also like digital matter is the most like looked up to, so I was lucky to have that, but at the same time I had to not do something which I don't